Hello there. In this episode, I will go over the compound interest questions in exercise 1L. To start off, the simple interest formula will be the initial price times the rate of increase, which is your interest rate, times the number of years, usually. And for compound interest, we will take our general formula over here. And we need to subtract by the initial amount, just for the interest part. If without the interest part, then you don't have to minus the initial amount. So in 1A, we're dealing with simple interest. So we can go ahead and do the initial amount times 6% in decimal. Multiply that over 10 years, and you should have $900 or 900 USD. For B, we also have simple interest. So let's go ahead and write down the amount at the beginning times the interest rate over 8 years. And that should be 3,200 pounds. C. So this is compound interest. We will use the compound interest formula with 2 to be my R. And this is compounded monthly, so I need to divide the rate by a factor of 12. And then I'll write 12 over there over 3 years. And if you put that in the calculator, now notice that that's the final amount, so I should really be subtracting off by what it was worth in the beginning. And if you do that correctly, you should get this number here. $875,000-ish. Part D, you have 300,000 pesos compounded daily. So we will take the rate divided by 100, and then we will take 365 as our day. Technically, it's more than 365, but we will just use 365 in this question. I think that's all right. And we want to multiply over 2 years. Remember to subtract off the initial amount. In this case, I have this much. Did I not subtract? Oh, no wonder. So I need to subtract the 300,000, and that should only give me 2,000-ish. That doesn't make sense though, because 2% should be higher. Oh, it's 4%. Yeah, that still doesn't make sense. It should be... What? Let me try again. Okay, don't know what I actually wrote down before. But the answer should have been this number here. And then for E, this time it's a monthly compound. therefore we have so we want to divide this by 12 times it by 25 then. Remember to take away what you put in initially. And I've got nothing. Okay, now I got something. This is the answer that I get. And, well, Swiss francs. And here I'm checking the answer, and the answer doesn't match up. Because I forgot to minus the initial amount again. Oops. I thought I did. Okay. Question 2. So a computer is bought for this much, but he wants to finance it off by paying off on a weekly installment. Now, we haven't actually talked about installments yet, so this may be something new. What is a simple interest? Because it's simple interest, then it will be just very straightforward. Basically, here, you want to find the difference between how much you have to pay off in total versus what the price was listed at. And that should be that for the difference. And then we want to finance that over weekly. How many years? 2 years. So we will take 52 weeks as the number of weeks in a year. We take this number and divide it by 52 times 2. So for a total of 104 weeks. So around 1,509.62 per week, which is a bit too small because I think I have missed a number somewhere. Oh, of course. That's just the difference. I messed up on the whole question, sorry. Trying to erase this. Okay, let's do it again. This is how much he actually ends up paying. So that means his weekly installment is, well, to find the simple interest rate, so what we can do first is, now this doesn't really specify what is the rate that they want. So we would just take it as an annual rate. So all we got to do is take the difference. It's too many zeros. And then we want to, so, well, let's write down the formula first. The interest equals P times R over 100 times the number of years, right? So in this case it's 2. And then we know that this is the interest. This is the initial amount. And for 2 years. So therefore the interest rate here will be the ratio of this, and then we want to multiply this by 100 and then divide this by 2. So in the first case, I missed another 0 here again. So simple interest per year will be around 3.38. For the second part then, I didn't really have to erase what I did before, even though it wasn't totally incorrect. But all you got to do is take the total amount of your pay and just divide it by the number of weeks within 2 years. So since I need to pay off the entire amount, not just the additional interest on the loan, so about 24,000. All right. So if a teacher makes a one-time investment and deposit 90,000 in the account for 5 years, the rate is 2.25% compounded monthly, how much will the final balance be? So this one is quite straightforward. You just do the present value to be 90,000, the rate at 2.25. So we want to further divide this by 12 parts. So therefore there will be 12 times 5 mini months. And then you just put that in the calculator. You can also use the TVM solver, but I'm going to demonstrate everything by hand. This will be what it's worth. Units is dollars, so put a dollar sign in the front. Okay, here we have a loan. So after 5 years of making quarterly payments in their car, she pay off the loan. She pay a total of this much. And if the per annum rate is 4.2%, how much was the loan for? So this is the future value. So therefore, we have the future value. We are now looking at the present value times 1 plus 4.2. This is quarterly payments, so that means 4 times a year. So this time we'll divide the interest rate by 4, but also put the 4 up here in the power. And this is after how many years? 5 years. So we have to manipulate just slightly. We just have to divide that multiplication factor on the right. Now if you're going to do this on the GDC app, make sure that you input the present value. I mean, well, in this question, it doesn't matter. In the last question, make sure you input the present value as a negative. Because in this question, if you do make use of the app, your present value just turns out to be negative, so you just simply write down the non-negative part. Which comes out to be, oh, this number is way too big because my number on the top is wrong. 26,410.17. And this is in Canadian dollars. Moving on. 5,000 today at this rate per annum, and then compounded monthly. How long would it take to double the investment? So that means we have 10,000 to be the future value, 5,000 to be now. Splits the rate into 12 parts because it's monthly. And then we have to do 12 times n, because we're looking for n. So when we divide this, we have just this part on the right. Now this number on the left is not coincident. This actually represents the doubling factor, right? Because you want to double. So technically, if you want the amount to triple, you will see that this ratio becomes 3. So I could actually just skip the very first sentence and just write down the right-hand side, the multiplication factor here, to be equal to 2. Okay, now we can, first of all, do I have to do the logarithm? This is looking for an, yes, I do have to do the logarithm. So in order to actually get rid of to bring the power back down, what we can do is take the log of both sides. And by using one of the log rules, we can actually write the power in front of the log so that this becomes a linear ratio. So the logarithm is basically just a function that returns a value, so we can take the ratio of the logs and then just divide this whole thing by 12. So then n is 21.36. This is in years. So does the question say anything about the time? I guess you can just say 21.36 years, roughly. Now let's show you how to do this on the GDC. Actually, GDC is quite straightforward. GCC is just putting all the values that you see up in the first line. So you skip all these hassles of writing it in terms of the ratio of the logs. So it could be quite powerful whenever you have to actually evaluate for the time that is required for such an investment to go from an initial value stated to the future value that you want. So here we will input our n to be, well, n we don't know, so whatever number it is, you can just leave it there for now. But here we have the nominal rate as 3.25%. Present value is 5,000, but it needs to be negative. Skip the payment. We want this to double, so here we want this to be 10,000, given that present value is now at 5,000. And we want to compound this monthly, that means 12 times a year. So after that, we go back to years and press solve. There's our 21.36, rounded up to 2 decimal places. Okay. Okay, let's look at this question. So we have a college fund started by Isabella's parents on her 5th birthday. So just one time deposit. And then they want her to receive 50,000 real by her 18th birthday. So if you think about the 5th to the 18th, right, this would be 6, 7, 8th birthday. So therefore, if this is 3 times, from here to here, that's 10 times, right? So we know that means that it's going to stay in the account for 13 years. And if it offers 5.5%, you want it to compound monthly, how much do they need to deposit now? So we're looking for the future value. So we have established that they want 50,000 by the end of 13 years. So present value is the unknown. And let's put down the rate, compound monthly. So I need to divide by 12, put 12 up here. And we want this to be 13 years. So again, we will just take the ratio of the left and the multiplying factor. 12 times 13 should be 156. And that is how much they need to put in order for the fund to grow to that much. So this should be BR. Good. So we have two guys here. They will give him £400 each. Oliver decides to put in a savings account that pays 1.25% compounded monthly. Harry puts in a mutual fund that pays slightly more, but compounded annually. If they don't touch the money for 5 years, who will earn more? Now, I said something that wasn't actually true. I mean, in this question, I think it's still true. But just because you have a higher nominal rate, that doesn't guarantee you that at the end they will actually, I mean, this doesn't promise that at the end it will be a higher return than Oliver, because it depends on the number of times that you compound actually. So let's do Oliver. He has 400 at a rate of 1.25, but monthly. So they both got to leave it for 5 years. And for Harry, it will also be 400. The rate is different. Also, this is on an annual basis, so just raise it to 5 here. So here's all the first amount. I will drop the units for now and just write it down at the final step. So Harry still turns out to be the winner. So Harry earns more. Does it say how about how? No, it doesn't say how much. I thought they have to find the difference. Okay. And the last question. Again, I think we have two options here, right? Ahmed has 40,000 Egyptian pounds. He has, oh, he's going to split it. Okay, so he has 40,000 and he's going to split it into two accounts. One at a simple interest rate, 1.2%. This is simple interest. And the other guarantee investment at 3.5. And this is compounded monthly, right? Okay. So we need to consider them separately. So we can say option A. So using the simple interest formula, we do, well, we actually do 20,000 plus the 20,000 at times 1.2 over 100 times how many years? 2 years. Okay. So that's how much it's worth for option A. And for option B, it will be 20,000 times 1 plus 3.5 divided by 100 times 12 is monthlies. So let's work out what they are worth. First option is 20,480 and 20,000 21,000. How long will he have to leave the money so that it earns the same amount? Oh, Oh, I read the question wrong. How long will you have to leave the money in the savings account so that it earns? Okay, so I should have figured out how much the GIC will earn because he's not going to leave this for 2 years only. But actually, it kind of gives you an idea as to what form of structure do you want, the question that you want. So we know that this is not enough. This is less than the GIC account. So the only thing that we can change is we can only change the number of years. So we will make that a variable. We'll just call that n instead. And we want that equates to the GIC's amount. So here, I'm going to do a lot of stuff. I will move the 20,000 to the right. And then I'm going to divide by this number and multiply the reciprocal of this. And then I should have n isolated. And I have 6.03. So roughly 6.03 years. And voila. All right, hope you enjoy it and learn something.